Eden was born from something deeply personal. When I was 16, my grandfather and my grandmom had died because of medical mistakes. At the same time, my mom was battling her second cancer diagnosis. I had seen firsthand the cost of failure in medicine.
I was always the odd kid. I grew up obsessed with mathematics in the middle of an oil refinery town in Mexico, but I knew I could make a dent in the world.
I have always been drawn to the intersection of medicine and technology. That path led me to become a neuroradiologist and to pursue a PhD in deep learning.
I saw what was being built in Silicon Valley, so I decided to move to California and study data science and statistics. There, I was in awe by the work being done in artificial intelligence at Stanford's AI lab under Felipe Lee, where I was able to participate in projects using AI for image generation.
But I've also experienced its miraculous potential. You see, I'm a modern medical miracle. I was born through artificial insemination. I was resuscitated at birth.
There I started to wonder, what if this technology, what if machines that can understand visual information could be applied to one of the greatest problems I knew? To early and accurately detect disease, so we may all live longer, healthier lives.
So I dropped out of high school with one mission, with one obsession, to make sure that no one else would die or suffer from later inaccurate medical diagnosis. That was the genesis of Eden.
I believe AI has the power to fundamentally transform how medicine is practiced. And when I look back, every chapter of my professional life, visiting professor at the Mayo Clinic, associate schooler at Stanford AME, director of the AI lab at the third largest diagnostic company in the world, it all feels like preparation. All of it has led me here, to this place, to this moment.
Well, it's good to see you all. We're here in San Francisco, the epicenter, the ground zero for the AI revolution. And after almost one decade of work, at Eden we're now uniquely positioned to build towards diagnostic abundance. And that means creating technology to make sure that no one else dies or suffers from later inaccurate medical diagnosis. And this comes from the convergence of different things. On one hand, the data mode we've developed over millions and millions of scans, billions of individual images that we have access through the deployment of Eden packs in today more than 2,500 customers, but also through a unique point in time, which is this extraordinary technological revolution that is going on with AI, that is enabling autonomous self-driving in the streets and now has a chance to truly revolutionize radiology and imaging. And furthermore, today, we're announcing that you, one of the most incredible minds in radiology, one of the best radiologists of your generation, is joining Eden as Chief Medical Officer. So I believe the first question is, Felipe, why? Why are you joining Eden?
Well, that's an easy question because you just explained it. I'm really thrilled to be part of this construction because I think Eden is very well positioned to solve this problem. And we know we have a huge problem today. We don't have enough radiologists, and that leads to a lot of scans to be read by each radiologist. That leads to burnout. That can increase the number of errors, that can delay diagnosis. And I think AI could solve that. But the problem is we always had a huge expectation on AI. For example, 10 years ago, almost 10 years ago, Hinton said AI would replace radiologists. That didn't happen, but what also didn't happen is the expectation that AI would really help us in every single task. And in my opinion, there are reasons why that didn't happen. There are some key problems that need to be solved. I'll just mention three of them. One of them is related to AI integration. Even if we had a very good model, if it's not properly integrated in a way that is seamless, in a way that is easy and that really helps radiologists, there's no effect. And having a PACS enables that. There's even no integration. It's actually inside the PACS.
Right. In healthcare, intelligence is not enough. You need to transform the workflow and do it natively for it to actually be adopted.
Exactly. The workflow is key. And the second thing is generalizability. There's no guarantee that a model that was trained in a specific data set will generalize to another data set.
Yep.
So having this huge data set across multiple countries help with that, help a lot with that. And the third one is related to data drift. Rai was mentioning how data
protocols
change over time.
Equipment changes.
Exactly. So there's no guarantee that model performance will be the same after 100 days, for example.
Right.
And having access to this continuous data collection helps with that. That's why I'm thrilled to be part of Eden and to be part of this construction.
Oh, welcome. And we're thrilled of having you here.
Thank you.
That's absolutely right. And you were mentioning about how it's been already more than a decade since we had these claims of fully automating radiologists or building super radiologists. With the previous era of solutions, you had this point solution, narrow applications where maybe you could find some findings automatically, but you didn't make a dent in radiology. The radiologists still had to do all of the work. But now with this new era of architectures, you can actually go from the image to the fully descriptive final report, which is what the clinician needs.
Fantastic. And that's where we want to get, right? And if we look at what the current scenario is, the best models that generate report are able to create reports that are accepted by radiologists without change in like 40% of the time. So it's way better than it used to be before, but it's still far from where we want to be.
Yeah.
So that's why I think we still have a lot of work to do.
To be clear, so we are developing these foundational models to achieve diagnostic abundance. And that is why you're here mainly, to help us get to that goal of diagnostic abundance. So you know very well where the state of the art is. In terms of data, in terms of F1 or area under the curve. So more than what gives you excited, also gives us a sense of how advanced you think Eden will be able to be based on all of these advantages that we've been able to build in the last years.
That is a crucial part of this because with narrow solutions using convolutional neural networks, we need the best ground truth we can get. But in this case, it's harder because the ground truth we have are the radiology reports. And there's no perfect way to automatically compare an AI-generated report to the radiologist report. And that's where the research is right now. And we are looking closely to what's being developed and leveraging what exists, and also adding our own opinions in some of these aspects to make sure we create the best way to validate these models. I think validation is key in this case.
Yeah, and that's extremely exciting too, right? When you see the state of the art, you have these validation sets done with a few individual centers or populations. So something that I'm also really excited about is now we can actually prove in a clinical setting that these models really work across a wide set of populations, countries, protocols.
Exactly. And like you mentioned, the problem now is related to all the findings.
Right.
So it's way harder to do that. But we are seeing people improving validation methods, and we think that's possible to be done. And that's where we want to contribute as well.
What do you think the world can expect from what we're building?
When we are able to finish the development of what we are envisioning here, I think we'll be able to achieve what you called the diagnostic abundance, to have diagnosis in a timely way and in a more precise way.
Just in terms of data size, we're orders of magnitude ahead of any of the most current publications, at least to the best of our knowledge.
Yeah.
But at the end of the day, what's the most powerful thing is that we're going to be able to deploy this to over 2,500 imaging centers, more than 7,000 radiologists across 18 countries, and get actual real clinical data from how these models are performing in the real world, not only on a specific test set or not only on a paper, but in an actual real world. And that's going to make the whole difference. And that is the path towards diagnostic abundance.
And the ability to naturally keep improving, right? If an inference is right, we will know right away. The radiologists approve it inside the system. And anytime that something needs improvement, we have that feedback immediately.
And just to go back to what you said at the beginning, more than radiologists burnout and more than the bottleneck that it's causing to healthcare systems, it's fundamentally a humanitarian problem, and it's trending to become a humanitarian crisis. In countries like Mexico, which is where we are from, or even Brazil, which is where you are from, a mammogram can take up to 8 months, even if the patient is symptomatic. I've heard rumors that PET-CT exams from last year are still without interpretation in most public sectors in Mexico. But this is a humanitarian crisis, and we cannot forget that. And I'm reminded of a patient that came to us when we were running imaging centers back when the company name was Eva. And she faced this. She faced 6 months delay to get a mammogram. The cancer spread. She died from metastatic disease. And I'm always reminded of this letter she sent to the Secretary of Public Health saying, it doesn't matter all the fancy technology they had, doesn't matter all the PR stunts or marketing campaigns they were doing. At the end of the day, she was too late. And while there are cases like her, while cases like that exist, then we have a lot of work to do. And we're not going to stop until no other patient suffers that fate. And the team is in place. Rai has assembled an extraordinary technical team. The scientific side, the medical side is going to come from you, and I think we're going to do a great team. And the data is there. Nothing is on our way to achieve diagnostic abundance. And we're very excited to show the world what we're building within the next few months.